Top work. Get him.
formula plug and chug should be fairly quick. Make sure you write your answer. Or if it's just formula plug and chug, make sure you write down what you plugged in and then the answer. If the answer can be written in terms of pi, so it's simplified, make sure you do that first, then a decimal approximation. Because we want to know the real answer, and then in context of a problem, that's when we might go to a decimal. Can everyone tell which part is shaded? Right side? It's a little bit fuzzy up there, but right side is shaded. Anyone still going? Yeah?
When it says unshaded, does it mean the darker or lighter part?
For the fourth time, the shaded region is on the right.
Got it.
While we wait for Tom to finish up, is anyone going to be gone on Tuesday next week? Remember next week, right? Yeah, Turkey Day. We have Wednesday, Thursday, Friday off. Is anyone, do you know you're going to be gone Tuesday? Okay. Because with our quiz today, that means our next quiz will be on Tuesday next week. Leading into a 5-day weekend of no homework. But if you miss it, then you're looking at a week gap between material and being able to make up the quiz. So, if I remember right, what's our maroon white schedule? That is a white day. If you two would like to get it out of the way on Monday, if you feel comfortable with that, I'm cool if you come down during Spartan time on Monday. We'll just knock out the review and the quiz then, if you want. Just giving you the option so you don't have that big week-long break between material and quiz, okay? Think about it. You got a week to figure it out. So, okay, arc length. Arc length is radians times radius. Diddle-oo. So if I switch 150 over to radians, 5 pi over 6, that's just 5 pi over 6 times 12. So 10 pi centimeters. Or about 31.31415926159, 159, so 6. Okay. I don't remember anything after 6. I remember 3.1415926 because 2015 was the Pi Day of the Century.
26, I bet they threw like an absolute rager.
We did. I was in Rapid at the alt school at that time, and the entire math department just did games all day long. We got local businesses to donate a crap ton of pies, so it was just games and pies all day long. It was pretty fun.
Did you guys have like a countdown like New Year's on 926?
Me and the guy next to me, we did, but I don't know about the other ones because they were on different floors. But so anyway, we got that, and then the area of the unshaded sector. Remember, that one is 1/2 radians times radius squared. But you got to be careful here, unshaded sector. So we're going to have 1/2 by 150 away from 360 is 210. 210 in radians is 7 pi over 6 times the radius squared. Getting 84 pi. Right? 12 and 12 cancel, 12 and 7, yeah. And then whatever that decimal is. Again, you didn't have to have the decimal approximations on there at all. It just, that was by 10, so I knew that one. Yeah, that's it. So did you... There's the thing. Oh, wait. There we go. So did you get correct answer? Get correct answer. Did you write down, because that's what we had requested, did you write down what goes where? If you did not choose to use the radians form of it, if you use the times x out of 360, also cool. Okay? But you have to have, here's my formula set up, here's my answer. Okay? What?
I got 7 pi over 12. Where did I do that?
Well, this is 7 pi times 2 12s. And then there's a 12 on denominator. I think you canceled the wrong direction. But that's
I'm confused.
7 pi times 12 squared. 2 times 6. 7 times 12 is 84.
How come when I put that in my calculator, I got 42? Okay, you know what? I'm just going to ignore it and think that I'm wrong. Because I am.
Okay. And then one for, because we made such a deal out of it last time. Having your correct units on there, including centimeters squared. Because y'all got stanky about it. So. Okay. Any questions there? All right. You? Any questions besides 37? Anything besides 37?
39.
Okay. And said there's a lot of things that, in terms of mathematical content and practice, if they show you the concept, they expect that you can extrapolate that concept, you can extend it out to a different type of application. I try to do as many examples in here as possible so that we don't run face first into that application and say, dude, what? I would have liked to have shown you this on Friday. Things happen. You have to cross the boundary that 1 radian is 1 radius. 1 radian is rotation. 1 radius is length. So if I'm given a linear and a rotational speed, then those two are technically equivalent. 82.3 meters per 1 second is equivalent to 131 revolutions per 1 minute. I can't compare linear with angular speed if they're not in the same unit of time. So step 1 is to make sure they're in the same unit of time. There's 1 minute to 60 seconds. Cancel, cancel. 1 revolution is 2 pi radians. I'm now in radians per second equals meters per second. They're both per second. So that means if I multiply both sides by a second, I now have so many meters is so many radians. I have length equals rotation. So I have 82.3 meters is my 1 radius. Compared to whatever 131 times 2 pi over 60 radians is 1 radian. If I want to know what my radius is, Jesus fish, solve your proportion. I want 1 radius is, multiply the 2 that line up, divide by the 1 that doesn't. Yeah. Okay. What I effectively have, oh, you come down here, you, yeah. Is a big honkin' proportion. I got those ones on the bottom backwards. Oops. But you get the idea. If radian equals radius, then I need to set radians equal to some length. And divide. I don't want this many radii, I want 1 radius. Cross multiply and solve. And then jam it into your calculator and whatever it is. Some decimal. Okay. 39, same thing. Inches per hour, revolutions per minute. I don't want hour and minute. Take that 0.09 revolutions per minute. Oh wait, other way around. So what's that? 120, 9, 12, 108. 10.8 pi?
Wait, says, wait, 2 pi times 360.
1 revolution is 2 pi radians. Definition. 0.09 times 60 times 2. 10.8. So if I know that 10.8 pi radians, if 10.8 pi radians happens in a minute, but 553 inches also happens in a minute, 1 radian is 1 radius. My radius is that. Okay? Or set up the proportion Jesus fish, but you got ones on the bottom, so same thing. Okay? You have to cross that boundary. A radian is a radius. It's real hard for kids to wrap their heads around that. That spinning equals tape measure. Like, length can equal rotation. That's really hard to wrap your head around. Okay? But if you cross that boundary, you can start doing things like, well, I know that I'm driving 60 miles an hour. I know that my tach says I'm running at 1800 RPMs. What's the radius of my wheels? How big are your tires? Well, I suppose that's not your tires, that's your crankshaft, but still. Besides those two, everything else go okay? All right. Then we're going to do some review and quiz stuff. But because Friday was a display of Skittles, we shall go to the copier and pick it up right now. Don't burn anything. Anyone have a lighter?
What?
I got something. I didn't, but like I just skipped like the first 2 hours.
Okay. I'm calling you guys. Does someone have a textbook?
There are extra ones right here.
If you go to the textbook, it shows you exactly how to do it. It's super easy.
It really is.
You literally just plug the equation.
What are you talking about?
Here, Andy, explain this to me. I didn't understand.
What do you?
Yeah, I
So
literally.
Andrew watches your ass.
Oh, my goodness, go pick up more stuff. Let's figure it out myself.
Oh, that.
That looked great.
Yeah, what do you guys do? Did you do that?
Which ones do we have to know how to do?
What you guys get?
I mean, so it gives you the box.
Yeah,
Right?
no.
Yeah, on the last one.
Claire, I want to make sure it's
Here,
I'll set it up. Here's where you can-
Theta.
This
That's what we just
Oh, yeah.
Yeah, let's we cross that one out. That's literally we were supposed to do that. I was like, oh. That was not copy.
It was on.
You set it up like. Why don't you go with everybody?
Yeah.
This day, this is- Yeah. I don't wanna do that.
Just grab a textbook and it's on page, I don't know.
You know the story? I need my friends.
It's on page 237.
Oh yeah. What stories?
No, all the stories. I make like my own.
Well, he doesn't have hot.
That's kind
Are you doing hot?
No, I didn't want to self-insert that.
Sure.
I killed myself.
Thousand and
There
two
should be. No, no,
Like
in
in-
my friends.
I'm like,
I'm gonna like make it better because I mean I just kind of like switched my thing.
You're
I just
hard.
made it past 9 seconds.
What's like the cheating on the test one?
I'm just trying to say like rough text. I'm not super worried about it.
I would share everybody in Harley's body.
no, I'm just saying.
I was like, yeah. It's not cold. Yeah, you just want to sound like uncanny. It's not like an actual page.
I don't know how to make it.
And then I think
My name.
My mom did last time. I was like, it's good enough.
So funny. That's the only way.
Yeah.
Just have to sit through
I only
like,
have
at the
200
end.
bucks.
Sit
You get all
She
of
was
them.
like facing
You get an hour and 30 minutes.
She pretty much was. She was. It's not.
do not do it all.
No. I mean, they're afraid to go. Oh no.
Yeah.
Let's see how many words I should do.
Yeah. I feel like she was.
I wrote 500 already.
That's true. Oh, I have not started studying.
It's not
I
about
did
hard.
2,000 for me.
You?
Yeah.
I got 100.
You're done?
Yeah, I'm done.
I didn't. I did wrong. And
She spelled it
I
like
spelled silicon wrong.
silicone. Silicone.
Silicone. That code is so silly.
Yeah, I spelled that wrong.
S-I-L.
And I spelled one other thing wrong.
I-E-I-N-E. I was like, did you spell rubidium wrong?
No.
I always thought
there was an H in there, but
there isn't.
The one I always got wrong was selenium or whatever.
Selenium?
Yeah, I got a 92 and 96. No, 96.
You know what? It's fine. If I fail, it's fine.
Actually, no, I'm gonna spend all my creating my work. Because I haven't done it yet. What? I haven't up till 10, like, writing like half my story, killing my friends.
Just say anything about it. Don't worry, guys. We got this. It won't be too bad.
Okay. Round one. There is one rat per person in New York City. A rat per person in New York City. Yeah. Below, fictional table, because I pulled a random table out of some other problem and just said whatever. Below is a table with data regarding the number of rats in thousands in the city in a given year. Find a logistic model. So it's not find the appropriate model. It's not you decide. It's just straight up find the logistic model. For the situation to determine how many rats are currently in New York City, let X be years since 1900. So, you all know the drill by now. If you got data in the table, start putting data in the table. Why? Is it on the other screen? It's on the other screen. Whoop. That was the last section of chapter 3, yes. Because we ended at 3.4 last time. So what do we got? 1940 and on. So I'm going to type in stat edit 40, 50, 60, 70, 80, 90, and 100. Over 22.6, 52.6. 102. And 158, 197, 216.6, 224.9. Double check your numbers. Look okay. I got data in. I want logistic regression because it's a specifically asked for a logistic model. So head over to calculate, find logistic, just like we've done how many times with other things. Store it in Y1 so you don't have to retype it, especially a logistic model because it's really gross typing it. Calculate, and remember, let it think. Don't come up and poke it a bunch while it's trying to do stuff. By the way, Claire, we are going to have a quiz today. Would you like me to demonstrate how that works? Because we talked about that, and oh, okay. And come over and just poke, 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 poke. Why can't you get this problem? What's wrong? So, write down your model. I have y is 229.962 over was it 1 plus 502.789 e to the negative 0.1 x, because rounding is a thing. Okay, I get my model and use this to determine how many rats are currently in New York City. So now that I've stored my model, I can go to my table, switch over to ask, and then what am I plugging in? 121. And you write 229.328 and you get it wrong. The table is in thousands. So 229,328 approximately rats. That's a lot of rats. Did we ever find the rat?
I thought you took them home.
No. Yeah. Someone was playing with it and started making inappropriate references about him being cold and whatnot, and then we, I don't know. Maybe someone stole the rat. About 229,328 rats. Because I can't have 0.4 of a rat unless we get creative.
Well, I mean, it's kind of what happened with the rat.
Squeak!
Yeah, like,
So some notes to make to this. A, read it. Please read it. Double check. What are the labels? What are the units? Is it in thousands? Is it in millions? Apply that to your answer. B, double check if they, again, big test bank, I don't remember which is which. If it asks for a specific type of model, find that model. If it says find an appropriate model, well, that's when you want to look at your stat plot, zoom to your stats, and then look at what type of shape is it. So like in this one, when I see a curve this way and that way, Well, I know it's not logarithmic, so I can toss that out. I know it's not linear. I can toss that out. I know it's not quadratic because it started coming back the other way. So maybe I would look at cubic and logistic. Okay? So if it says choose the appropriate model, you have to look for what is appropriate. Which models can I toss out right away? Then look at their correlation coefficient. How do I decide? Because remember, if I have something that has that exponential increase, you have exponential, power, maybe quadratic, maybe cubic, logistic. How do I choose what the appropriate one is? Like in this, it asked how many rats are currently in New York. Look at your data. Look at your table. How far does that data go out? Okay, if it only goes out to 2,000, and I'm extrapolating, if I'm going past my data set, I want to use the one that makes the most sense logically. If I were to carry this out as a, say, a exponential model, then maybe in the year 2021 it would say that there's 9 billion rats in New York. That wouldn't make sense. So you have to choose the model that makes the most logical sense. If you're extrapolating, if you're interpolating, if you're going inside your data, you just pick whichever one's got the best fit. Okay. Then, SOHCAHTOA. It's a right triangle. Tell me stuff about right triangles. Stage 1, solve. If I'm going to solve, I'm going to solve as exactly as I can. In this case, I've got two sides. So if I find the third side, I probably want to actually use Pythagorean and get a simplified radical. So 35 squared, 900, 3, 150, 300, 1200, 1225 minus 400, 825. I don't even know.
5 times the square root of
5 squared of 33? Okay. So whatever 35 squared minus 20 squared is, and then simplify your radical. Once I have that, finding all 6 trig ratios. Oh wait, we have to continue solving. Measure of angle A. From angle A, what was I given? Opposite, adjacent, or hypotenuse? Words. Adjacent and hypotenuse. So I will do the arc cosine of adjacent over hypotenuse. If you reduce that down and call it 4/7, it's not going to change your answer. I'll take both because it's part of your work. Measure of angle B would instead be the arc sine. Now remember, you can find one, and then because they're complements, you can just subtract from 90 to get the other. You don't have to do the full calculation for both. If you just found one, subtract from 90 and said approximately whatever the other one is. I'm pressing the sine and cosine buttons. What should I be really careful about right now? Well, yes, we have to use seconds, so we do the arc function of it, but am I in degree or am I in radians? Every time you reset a calculator, like say for example, you still had regression stuff in your calculator from the last time we did it. You got to number 1, didn't want to clear stuff out to do your new regression model, so you just flipped it over, stabbed it, and now it was reset. It's going to default back to radians. So please be careful. Find these in, I mean, if you want to write it in radians, fine, but you better write it in simplified terms of pi, radians. most of us are going to probably want to just say approximately so many degrees, and I'll be okay with that. Then your 6 trig ratios. We have sine, cosine, tangent, cosecant, secant, and cotangent. Are sine, opposite over hypotenuse, reduce it down. Oh wait, we're going from A. Yep. From angle A, sine is opposite over hypotenuse. There we go, square root of 33 over 7.
If we don't simplify it, it's not. We have to simplify it.
Yes, always. And then 4/7. And then 5 root of 33 over 20, again reduced, root of 33 over 4. And then flippity-flop all of them and rationalize them, 7 root of 33 over 33, 7/4, and 4 root of 33 over 33. This one's got a lot going on. Yo. What? Because it was over 20 or 35, and that reduces. What's outside of radical land reduces with what's outside of radical land. Okay? If you forgot, oh, the thetas? You'll get the frowny face of doom.
That's it?
Yeah. No, no points off for that. Yeah. Okay. You notice there's a lot of stuff going on there. There's also only 5 questions. That's on purpose. When there's a lot of things going on, that just means that each one's going to be worth a little bit more. So maybe some notes to write to yourself. A, make sure you have simplified radicals, simplified fractions. Rationalize your radicals. Don't leave a square root on denominator. Make sure that you're in degrees when you start pressing buttons. Yeah, just be careful. Maybe label it opposite adjacent hypotenuse when you start the problem. All angles coterminal with. Well, that was easy because we just said negative 225 plus 360 n, where n is an integer. That's what I need. If you want to say all x's such that x is this, okay. Otherwise, with the orange part, I will just assume that's understood. But you do have to say n is an integer, because otherwise, if you add part of a revolution, it's not actually coterminal. And it says, draw and label in radians a positive and negative coterminal angle. So I need to take that negative 225 times pi over 180 to turn it into into radians first, and get a negative 5 pi over 4. So if my original is negative 5 pi over 4, what quadrant is that in? I'm seeing everyone just like pointing. 2. Negative 5 pi over 4 means we're going to rotate clockwise. So I'll cut this up because I know pi is here, 0 is here. So I need to go 1, 2, 3, 4, 5 quarters clockwise. Then, positive coterminal angle. I'll take negative 5 pi over 4 plus 2 pi, which is 8 pi over 4, getting 3 pi over 4. If I want the negative coterminal angle, negative, what? No. Negative 5 pi over 4, subtract another 2 pi, which is 8 pi over 4. It's a negative 13 pi over 4. You get to your angle and then continue another revolution. Please, even though you're technically right, don't be the kid that gets all spirally on it and wants to add like 8 revolutions for your coterminal angle. All right, just keep it simple. All right. Yes.
Why?
Pedantic.
Interesting.
Okay. Anything on that?
His initial stuff is S.
That was one of the 3 kids that did it, yes. Yes.
The other one, JS.
No.
J was next.
I don't think J was that. Because you add
Hi.
pi, you subtract
Still valid.
Since it's saying like in radians, if you have to do it the very
Yeah, we already did.
instead of plus 360 degrees and you
This
have
is
to do it plus 2 pi
13 pi
and
over 4.
Yes.
So you always start here.
I don't.
Right?
That's another thing. What if the original says all angles coterminal with negative 7 pi over 6? Yeah. So if it was in radians, then it's plus 2 pi n. N is still an integer. If you're trying to find coterminal angles, you either add or subtract 2 pi or 360, depending what unit of measurement you're in. Yep. That would be a note to put on there to watch for is be careful what it's asking for. Is it asking for the answer in radians or is it asking for the answer in degrees? Note it does say draw and label. Even if you label it off to the side, that's fine, but I'll have some kids just, I don't know how to do this radian stuff, so I'm just going to draw and then move on. But look, I drew them. Okay, so just be careful with that. Well, we did do a bunch of unit analysis stuff. So, unit analysis stuff. A clock is divided into 12 sectors. Well, yeah, look at a clock. Okay. If a full revolution is 2 pi, then I take that 2 pi and divide it into 12 sections, and each one is worth pi over 6 radians. What is the angular velocity of the minute hand in radians per minute? So I need to state, what do I know about minute hands? How long does it take to complete a revolution? 60 minutes. So I can say 1 revolution in 60 minutes. Now, if you said 1 revolution in an hour, you would just convert that, right? So however you state it, I know that this happens. That many revolutions to that many minutes. I want to know radians per minute. And I know that 1 revolution is 2 pi radians. Cancel, cancel. Pi over 30 radians per minute. What is the linear velocity of the second hand in feet per hour if it's 10 inches long? What do you know about the second hand? 12 hours. What? How about one revolution is equivalent to what? 60 seconds. Or one, I'm going to say 1 minute just so it's one less conversion. Okay. 1 revolution per minute. I know that. Okay. If I want to know miles per hour, feet per hour, then I have to cross that boundary of a radian is a radius. So start by getting in radians. Okay, I want feet per hour. Right now I'm radians per minute. So I'll take that radians and say 1 radian is equivalent to 1 radius. Do I know the radius of the second hand? 10 inches. I'm now in inches per minute. I don't want to be in inches per minute. Well, look at the second hand on a clock. Is that the radius or the diameter? Ah, sneaky, sneaky. If you're not counting the little stub at the back on some second hands. Okay. So, I'm in inches per minute. I want to go to feet per hour. So I'm going to say there's 12 inches to 1 foot. And there's 60 minutes to 1 hour. Because revolutions with revolutions, radians with radians, inches with inches, and minutes with minutes. I am now in feet per hour. So I got 2 by 10 by 60 is 120. Over 12 by a bunch of ones is just 10. So 10 pi feet per hour.
So what is the 2 pi radians over 1 revolution?
Because I started in revolution.
Isn't it 100?
Isn't it 100?
What? 2. Oh, I missed a 0. Because that's 2 by 10 by 60 is 20 by 60 is 1200. Over 12 is 100 pi. There we go. Yep. You cannot go from the second hand being angular to linear velocity being... You're not going to go from angular to linear without crossing the boundary. 1 radian is 1 radius. Okay? Rad en is 1 radius. Rotation, length. Okay? You can't go from angular to linear or linear to angular if you don't cross that boundary. That's why we have radians as a measurement. It allows me to cross that boundary. Okay? Which would be a really good thing to have written there. Because I guarantee you, you're going to have to cross that boundary in one of those 2 problems. probably like this. One of them is going to be nice and simple. The other one's going to be got to do a little more. And you're going to have to cross that boundary. Okay? And you're not going to be able to cross that boundary if you don't get to radians in the first place. And finally, the application of our right triangle stuff Sarah's on the ground, sights, top of steep cliff, 60 degrees. She backs up 50 meters, and now it's at a 30-degree angle. She's 1.8 meters tall. How tall is the steep cliff to the nearest meter? To the nearest meter, that's what happens when you copy and paste. No. 3 places, 10 thousandths, or to the thousands. Words are hard. So I know that the tangent of 60 is opposite over adjacent. I know that the tangent of 30 is opposite over adjacent, which is an entire 50 plus y. If I want to know what x is, I should probably swap my extremes, or cross multiply or whatever, and say x is y times tangent of 60. Or y is, which one's better? Should I say x is stuff and replace x? Or should I say y is stuff and replace y? I would replace y because I'm trying to find x. Okay? So I'm actually going to say y is x over tangent of 60. I'm going to swap my extremes here, say 50 plus y is x over tangent of 30. So do you see if I subtract y here? And then replace y with stuff. We got 50 is x over tangent of 30 minus x over tangent of 60. We ran into this before, and whenever kids get here, we're like, well, can I just, like, x minus x is 0 and no solution? Now,
Yeah.
how about I factor? What do they have in common?
A tangent.
Boo! How about an x? How about 50 is x times this ugly mess? Oh, that's 30. Frank's a little cross-eyed in the corner there. So, if I want to know what x is, take 50 divided by that mess. I'm okay with you giving the decimal for it. 50 divided by 1 over tangent of 30 minus 1 over tangent of 60. I suppose I should go finish off those parentheses, huh? I'm about to get the wrong answer.
Because you're in radian.
Okay. Window. Mode. There we go. Switch me over to degree. Then 43 and change. No. You might have to find the length of the zip line from the cliff down to stick figure Sarah.
Wait, so does her height have nothing to do with this?
This is X. I just found X. Do I know how tall the cliff is yet? Now we add in stick figure Sarah as 1.8 meters. Excuse me? Oh, it just randomly decided not to have the answer. Okay, so that plus 1.8. Now, if you had gotten common denominators, dividing by fractions, easy as pie, flip, second, multiply, all that kind of stuff. If you had said 50 tangent of 30 times tangent of 60 all over tangent of 60 minus tangent of 30 plus 1.8. Well, I suppose if we're going to go that route, 1.8 is 1 and 4, so 9/5.
I'm just getting confused.
If you wanted to write it as a simplified expression by getting common denominators and combining it into a single rational, you can.
No,
You don't have to.
I'm just confused
No,
now.
just decimal. Just take 50 divided by crap. Add 1.8. Okay? Notes to yourself. Don't forget stick figure Sarah, if that's involved in the problem. Okay. It's okay to factor out an x. It's okay to write your work as big, ugly fraction. Be careful as to whether you're using sine, cosine, or tangent. I've had some kids do better with these type of problems by making two separate triangles so that they do better with what the actual opposite and adjacent are. Okay, however you do it. Now in this particular problem, there was an easier way, specifically because of the angle measures. Remember linear pairs? If this is 60, this is 120. If that's 120 and that's 30, then this is also 30, making it an isosceles triangle. So if this is 50, this is 50. So since the sine of 60, or not even that, remember, divide by 2 times square root of 3 plus stick figure Sarah. Specifically because of the 30 and 60. I did it the other way because it doesn't work out that way on the quizzes. Okay? Boy, don't we remember lots of geometry? Devices over there.
Apparently there's like 2 million rats in New York.
Scramble yourselves up.
Are they talking about the people though, or like
Rats.
the people?
I agree every time.
Not just Mosquito.
That's not true.
I think that's the right guy. I hope.
I was really good. Honestly, I've never been to sound. I won't. Can you do a test on Shambo?
Maybe. I don't see why not, honestly, I guess.
He's a fun stuff. Oh, this is cold.
You have plenty of time.
Algebra 2.
Close.
Oh, that's
Did I just completely miss a Lars?
Yeah.
Got 25 minutes for 5 questions. Go.